So what do you notice about this particular problem that we want to simplify? Notice that it's in fifth root world. The index is a 5. So as we look at each of the individual terms, we need to think about, well, what are factors of those terms that work in fifth root world? So for example, 64. What's one of the factors of 64 that's a perfect fifth? That's a 32. So 64 is 32 times 2. Why did I choose 32? Because I know 32 is a perfect fifth. X to the third. What are the factors of that? That's a perfect fifth? There aren't any, so that remains x to the third. Y to the seventh? Well, that becomes y to the fifth times y squared. And then z to the 29th. What's the greatest factor of z to the 29th that's a perfect fifth square or a perfect fifth root? And that would be z to the 25th times the leftovers, which is z to the 4th. So from there, I was able to take each of those terms and factor them into a factor that's a perfect fifth. So the fifth root of 32 is a 2. I can just pop that guy out. The fifth root of 2x, or the fifth root of 2, 2 is not a perfect fifth, so that remains within the root. X cubed, the fifth root of x cubed, is just still the fifth root of x cubed. The fifth root of y to the fifth, that reduces down to y. That's why we broke up the y's into y to the fifth times y squared. Fifth root of y squared remains the fifth root of y squared. The fifth root of z to the 25th is z to the fifth. And then the fifth root of z to the 4th is z to the 4th. So my final solution in simplified form is 2y z to the 5th with the fifth root of 2x cubed y squared z to the 4th. I want to double check all the remainders underneath the radical here and see if there's any other terms that maybe I did not reduce fully, but each of these terms does not contain a factor that's a perfect fifth or with a perfect factor in fifth root world.